for lunch here. This is Felipe Gutierrez. He's from AMC in Amsterdam, and he's going to be talking fair sequencing data repository based on iRODS.
How come this picture is not up there? I'm just kidding. Oops, sorry.
So hello, my name is Felipe, and I work for AMC that's Amsterdam Medical Center. I work as a research software engineer there, and we are building a prototype that we call fair sequence data repository based on iRODS. So first I'm going to introduce the problem that we have. So currently we have a lack of dedicated RDM solutions at the AMC, and each research user has their own way to store data, metadata, and backup this data. So they store in their own computer, and the backup is on some external hard disk. Also, the metadata is generally not stored with the NGS data, and most of parts of the metadata is disconnected to the data. And furthermore, the metadata does not follow any FAIR principles. That is like the last presentation from Paul. We have also the same problem. And so the metadata is not findable, is not indexing any database. It's not very well accessible because it's just one computer that you have to access the data and metadata. Interoperability is not considered, and the reusability comes difficult with this scenario. And yes, here is some consideration about the project. And when we start this prototype, we realized that our position is on the blue box of the left upside. So we have to keep our clients very satisfied, and to this we have to be very close to them. This is kind of difficult to us. All these things happens because our IT department has their own computer to work, so we have everything that we do in our network, we have to pass through them. Our research computer has their own computer to work, so they work. The way that they are working is good, but not very well. So they have low interest to use our prototype. It means that we have to build something very easy and easy to use. And we need some sustainability vision because we have different research users to use our prototype, and each one has their own way to work. And and our prototype has to start on very small and grow as we go our system. These pictures, I want to show our, sorry, I want to show our ecosystem of research data management. So we can divide this ecosystem in 3 parts. On the left side, we have different storage resources that we use at AMC. On the middle, we have one enterprise data warehouse that each research has their own way to extract data and metadata, transform this data and metadata, and load. And on the right side, they have some computing process with this data and metadata, and finally to store and to publish this data. So our prototype has to fit on the red box there. And because of this, we have to build a prototype that is distributed, scalable, and easy to use in this this big ecosystem that we are. So with this problem in mind, we came to some system design that we want to use iRODS because we can build our system and grow our system as we go and start very small. Also, we are using Virtuoso storage, that is triple store software to work with ontologies. And each one has their own way to store data and metadata. On the top, we need to have some client interfaces to make the user research easy to use our system, because it's very difficult to help them to know iCommands, so we need some easy user interfaces to them. And on the right side, we need to apply some RDM policies and security because the data is very sensible. So this is a more detailed system architecture for us. We are using 4 different client interfaces. Also iCommands, we are releasing iCommands today, and also some web interfaces like iRODS Cloud Browser, Metalnx, and Davrods. With Davrods, we came to this easy way to release some solutions today because we just drag and drop files to the iRODS, and implicit we create metadata for this data. These yellow boxes means that we have some rules to execute to create metadata with the data that we ingested. And yeah, we have some landing zone and persistent zone. So every data that we ingest on the landing zone, we process with the microservices and rules. We create some metadata, ingest the data and metadata into iRODS and also into Virtuoso. So we are using Virtuoso to enrich the metadata from iRODS. And the Virtuoso conductor is just a web interface for Virtuoso. So one of the requirements of our project is to have different flavors of interfaces to the users, so they can have different options to work if they don't know iCommands yet. This is our description of our ontology that we created. We have 4 types of ontologies, and with these ontologies we enrich the metadata from iRODS. And this is 3 step slide that I created just to show that we divide our rule in 3 steps. So we start with ingest metadata, process metadata, and retrieval data and metadata. So to ingest data and metadata, we are using some CSV file, sample sheets file, and all the data that I described here as a FASTKey files. So every FASTKey file has to be described inside the CSV, and we ingest this using Davrods. It's just a drag and drop user interface that everyone can use in Windows, Macintosh, and Linux. So it becomes very easy for everyone to use if they have this mountain drive. So the second step is to process the rules. After the data and CSV file comes inside the landing zone, we process using rules, microservices, and ingest this data and metadata into iRODS, iCAT, and Virtuoso, and enrich with ontologies. These 3 steps, we have sub-steps inside this that we can have more detailed information of what is happening under the cover, under the roof, sorry. And the last step is just to retrieve data and metadata. So we are releasing 4 types of client interfaces. Davrods just retrieve data, but if for ingest data, we say that implicitly we are creating metadata with Davrods because we have our rules doing this. this table is just to show the different client interface that we have and the different kind of users that we have access our system. So as we see, the normal user, that is the research user in blue, has access for all the client's interfaces, but he's not able to access all the functionalities of the system. Like the PI, the principal investigator, has more power at our system, and he's using only 2 interfaces. And data storage, that is a user that can help the research user if something inside the sample sheet is wrong described, is not our standard format. Yes, and I forgot to say our standard, we are following Illumina standard, and as much as possible, because each research user has their different way to work. Yes, and the admin role that is responsible for create more rules for different groups and work with security of our system. So every time that we add new user, we apply this user for different group, and because they have our system has different groups, we have one rule for each group to execute. So these are just 3 screenshots of our system. As you can see on the top, you have landing zone where we drag and drop files. And after we process the files, we create metadata on the persistent directory, data and metadata. So on the right side here, we have the report file that we can describe all steps that we did with the rules. And some TTL file and an XML file. The XML file contains all the metadata that we ingest into iRODS. So you can open this XML search, or you can use iCommands or Metalnx or iRODS cloud browser to search metadata and data. And TTL file is to ingest metadata, triple stores into Virtuoso. And these 2 screenshots is of Metalnx that we search data using metadata, and we can admin our prototype, our system. This is the report file that we created, and we are increasing the number of messages on this report file. On the header of the file, we had some information just for the research user, so he can see which sample sheet he ingested, if the final status is completed successfully or not, and the data. And for the data storage that has more ability to work with the sample sheet, and with the system, you have some detailed message of each step that it passed, and how long it took. And if there is some message that is not okay, the data storage can go directly to the exact point of the sample sheet and fix the standard, fix the metadata. Our approach to see how our prototype is going, we are measuring some qualitative and quantitative ways. In this slide, we just, it's not very, like, how can I say? We are using just virtual machines, our environment, so we don't have a lot of big files, but we decided to measure something just to see how the systems work. So we are using Animal. I don't know if other people use another software to measure, but it's the first option that we had. And this is we reach about 180 megabytes per second of read into iRODS with Davrods. So, and for write, we reach about 36 megabytes per second with iRODS and Davrods. So we are using WebDAV above iRODS. So it's why sometimes we are not writing parallel. And yeah, the IOPS of our storage system. The qualitative questions that we are asking for the users are about the metadata preparation, if everything is clear, doable, and easy to do. The metadata upload, if they are upload a lot of files or few big files, because it makes a lot of difference for us. About the rule processing, if the report file is clear to them, if they can recognize the error on the sample sheet and fix this. And how is the data retrieval for them, if it's as much as fair possible, like findable, accessible, interoperable, and reusable. And the last item is just for quantitative questions, like as I said on the graphs before, if the size of files, if the throughput is good enough to them. Yeah, that is it.
Anyone like a question? All right.
Thank you. We have lunch ready after our group photo. We are going to go find